Right, so we are back again here. Question 5. Right, the diagram below shows the graphs of g of x equals t over x plus p plus q, and f of x equals the log of x base 3. Right. Y equals -1 is the horizontal asymptote of g, as can be seen in the diagram. B has the coordinates 1 and 0. Is the x-intercept of f. Okay, you can see that. A has the coordinates t and 1. Is a point of intersection of f and g. The vertical asymptote of g intersects the x-axis at E. Okay, we can see the point E. And the horizontal asymptote at D. Right, OB equals BE. OB equals BE. Right. We have OB equals BE. All right. And that is clear there. Okay, let's look at the questions. If all that is being said, we've already read the given information. So we answer 5.1. Here we need to write down the range of G. What is the range of G? And obviously, in view of this question, it is clear that G is the rectangular hyperbola. And therefore, if we are looking at 5.1, right, to find out the range of G, the rectangular hyperbola, we proceed as follows. Right, so the range is the set of all real numbers y, set of all y which are elements of the real numbers, but we remove the asymptotes. So we remove y equal to -1 there. All right. Also, there are a couple of ways to do that. You can state it like this, or you can say y is less than 1, y is bigger than -1. Or you can say y is an element of the interval -infinity to -1, or y is an element of the interval -1 to +infinity, or you can say y is an element of the interval -infinity to -1, union -1 to infinity. Okay, a couple of ways to write the solution there. Right, so we're looking at the next question. We want to write down the equation of G. The equation of G. How do you write down the equation of G? Okay, we can see that G is a rectangular hyperbola, so we just have to realize the asymptotes, and therefore we are certainly on point. Okay, so if you look very carefully, the point D has coordinates. What are the coordinates of the point D? Right, so the coordinates of the point D can be read off clearly from the diagram. Right, you have seen that OB equals BE, and this gives us it's OB equals BE. This means the coordinates are 2 and 0 here, and therefore the coordinates of D are x equals 2 and y minus 1. So the point D will have coordinates 2 and -1. Right. And so the equation of G, so in other words, at this point of this gives us x equals 2, y equals -1. So we have G of x, which is 2 over x plus p plus q. 2 over x, which is x plus, which is actually x minus 2, x minus 2. Right, so you have here x minus 2. We have x minus 2, and then the q is -1, which is -1 like that. Let's look at 5.3. Calculate the value of t. Right, in view of this, you can see that t is at the point of intersection is the x coordinate of the point A, right, in the diagram. You can use any of the points, any of the functions. Okay, so using any of them, of the functions, I can use, for instance, I can say using f of x equals the logarithm of x base 3. All right, and we can realize that at the point A with coordinates t1, we have x and y. So y is 1, which equals the log of x, which is t base 3. And therefore, what this means is that t is 3 to the power 1. And this means that t equals 3. Right. So we found the numerical value of t in 5.3. In 5.4, write down the equation of f inverse in the form that. So let's look at that one. Right, so in 5.4, want to write down the equation of the inverse. Right, so the equation of the inverse in 5.4. So you first write like this, right? You say f is nothing other than y equals the logarithm of x base 3. Right, next we look for the inverse, and the inverse is x to the log here of y base 3. Right, so from this you can be able to solve. So this implies that, right, y is equal to 3 to the power x. And this is the answer. It is exactly in the form y equals 3 to the power x. Next, we answer this question, 5.5. For which values of x will the inverse be less than 3? 5.5. 5.5. Which means that you have the inverse. Now, recall that from the above question, the inverse is 3 to the power x, which means that we are saying here the inverse is less than 3, so which means we are looking at 3 to the power x less than 3. Okay, so you can put the 3 to be 3 to the power 1. All right, and therefore, if this is the case, it means that if the bases are the same here, it means that x is less than 1 as we compare the exponents. Now we look at the next question, 5.6. And 5.6 is determine the point of intersection of the graphs of f and the axis of symmetry of G. The axis of symmetry of G. Okay, because you can see the graph now. The graph of f is the log function, so it is this one here. Right, we're interested in finding, so it intersects the axis of symmetry of G. Your intersect axis of symmetry of G that has a negative gradient. So at this point, the axis of symmetry of G is this one here. So this is this one here. Okay, those are the lines of symmetry. But the one with a negative gradient is actually this one here. It has a negative gradient. Okay. Right, so if this one here has a negative gradient, what do we get out of this? Right, we get the following. We get the following. So we're gonna therefore analyze this question. Let's see that. So we're going to equate the two functions. So we must first find the equation of the axisymmetry this examiner is speaking about. So I'm going to do it here. I'm going to do it here. Okay. I'm going to do it straight away here. Now, first things first, we need to realize. So we have 5.6. All right, so we have that y. Sorry, the equation of the equation of the axisymmetry. Or the axisymmetry. If you don't want to say the equation of the axisymmetry, you can just say the axisymmetry. With a negative slope is minus x plus c. But it passes through okay, it passes through the point D with coordinates 2 and minus 1, in which case you have x and y. So which means that y is minus 1 and then x is minus 2 plus c. Right, solving for c here, we have c equals 1. And the observation is therefore that y is minus x plus 1. So this equation of this line is minus x plus 1. And then we are asking the question of the point of intersection. Right. So we continue as follows. Right, so I'm going to erase to create a little bit more space here. I'm going to erase here to create a little bit of space here. Okay. Yes, my brother. Yes, my brother. How are you? Yeah. Oh, 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 all right. That's fine. Oh, yeah. I'll tackle it now. Okay. 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 Thanks, my brother. Thank you. All right. Okay. Thanks. Right. So we continue with this one. And now we have the following. We have the following. We have the following. We have the following. Right, so at this point, what we're getting is the following. Right, we take note of the fact that the x-intercept the x-intercept for the x-intercept of the axis of symmetry is at x equals 1. Okay, when y is 0 there. Moreover, we note that the function f has an x-intercept There's an x-intercept. Let B with coordinates 1 and 0. Okay, it is given there, which is the same as the x-intercept of the axis of symmetry, which is the same as the x-intercept of the axis of symmetry. Uh, and therefore, the observation clearly is that the point of intersection point of intersection but the point of intersection is actually the point B with coordinates 1 and 0. Okay, so we have solved 5.6, and with 3 marks, we are done there. We are done. Okay, so thank you so much, and a very goodbye to you.